Hey guys, it's Miss Miklos. We're going to finish up this set of notes, and now we're moving on to the different properties of addition and multiplication we're going to deal with. Some of them are going to be ones you're really familiar with, and some of them are going to be totally new to you. And as I stated in the previous video, all of these properties are going to be really important in our next set of notes. These are just all like the little foundational skills we need in order to understand the new concept we're going to be learning. So the first property we're going to be talking about is closure. Closure is defined as any result of an operation is a member of the original set of elements. So basically what that means is a set is closed if the output is a member of the set. So it is important that we know what type of set we're talking about. For example, we would say that addition is closed under the set of integers because if I add two integers together, I will always get an integer back. For example, 4 plus 2 is 6. 5 plus negative 2 is 3. Any two integers added together will give me another integer. Something that would not be closed, we would say that like subtraction is not closed under the natural numbers, because if I did 2 minus 7, I would get -5, and -5 is not a member of the natural numbers because it's not a counting number. So hopefully that explains a little bit what closure is. Our next property we're dealing with is something you're more familiar with. It is commutative. The commutative property means that order changes. So we can change the order and it's completely fine. For example, A plus B is equal to B plus A. A times B is equal to B times A. The other one that you guys are really familiar with is associative. In the associative property, grouping changes. And often we think of grouping as our parentheses, but it is important just to make sure that if we see parentheses, that doesn't mean we're talking about the associative property. We need to make sure what's inside the parentheses is actually changing. For example, the quantity, whenever we read parentheses, we use the word quantity to kind of alert everyone that that's what's coming up. So the quantity A plus B plus C equals A plus the quantity B plus C. So that would be our associative property. Our next two properties, identity and inverse, are probably things you have not talked much about. Okay, what the identity property means is that it is an element that causes an operation to result in the same as it starts. For example, in addition, what can we add to 6 to get 6 back? Well, we know that we can add 0 and it's going to give us our original number back. And that's true for any number in addition. In multiplication, what could we multiply by 5 to get 5 back? Well, we know that we can multiply 5 by 1 to get 5 back. So we call these numbers our identities because doing the operation with these numbers gives us back our original element. It gives us back what we started with. And it is important to note that there is only one identity element for each operation. Our additive identity is 0 because we can add 0 to any number and get that number back. Our multiplicative, it's a fun word, try and say it, but our multiplicative identity is 1 because if I multiply anything by 1, I'm going to get that number back. Once we know what an identity is, then we can kind of talk about an inverse. An inverse is the element in an operation that creates the result of the identity. So basically what that is talking about is what can we add or what can we multiply by to get the identity back. For example, 8 plus something is equal to 0. The reason why we're choosing 0 is because that is the additive identity. In this case, 8 plus -8 is equal to 0. So -8 would be the inverse in this particular problem. Now, if we think about it, negative 8 is not always going to be the inverse. If I did 5 plus negative 8, it's not going to give me 0 back. But we can kind of think, what's the relationship between 8 and negative 8? And we call these opposites. Okay, so I can always add the opposite value and it's going to result in giving me the identity. In multiplication, if we think about it, if I have 4 and I need to multiply by something to get 1, I would multiply by the reciprocal. So 4 times 1 over 4 would be 1. So to get the inverse, for addition, we add the opposite. To get the inverse for multiplication, we multiply by the reciprocal. Our final property is the distributive property, and the distributive property is very unique because it is the only property that we talk about both addition and multiplication. In fact, it brings those two properties together. For example, A times the quantity B plus C equals A times B plus A times C. So that is our distributive property. Every other property that we're talking about today, we need to be specific, like that's the identity property of addition, or that's closure of multiplication. With the distributive property, we can just say distributive because it's both of them. So there's a few examples here that we want to go through. The first example, the quantity 3 plus 9 plus 8 equals 3 plus the quantity 9 plus 8. Often when I'm going through these problems, and keep in mind these are kind of easier examples, but the thing you want to ask yourself is what changed from the left side of the equation to the right side of the equation. And if we look at this, we can tell that whatever's inside the parentheses, the groups, are changing. So we know this needs to be the associative property. Since we're dealing with addition, our answer would be the associative property of addition. And notice, like on my notes here, I didn't write property. Like, that's fine. I'm not nitpicky on that kind of thing. But we do need to definitely say it's associative and mention that it is of addition. Okay, number 2, we have 14 times 1 equals 14. So in this particular problem, we're doing 14 times a number is getting us back to 14. Well, we said the identity gets us back to the original number. So this is the identity of multiplication. You could also write the multiplicative identity, and that would be correct. Number 3, we have 6 plus 11 equals 11 plus 6. And if we're looking at this, what's changing? Well, the order is changing. The 6 and the 11 are switching spots, so we would say this is the commutative property of addition. And number 4, 6 times 1 over 6 equals 1. We are multiplying 6 by something to get 1 back. 1 is our identity, so this is the inverse because the inverse gets us back to the identity. Okay, so kind of to sum up things that I think can be tough to remember, closure means that the result of whatever operation gives us an answer or an output that is a member of the same set. Identity gets us back to the original number. Inverse gets us back to the identity.